And so let's look at the problem that needs to be solved. Now we have a logic diagram that works like this way. 1. The main process is created, general.js, for which one core is allocated. 2. The heavy script starts to run. 3. The system refuses to execute other requests, as it is overloaded with a heavy script. Let's look at a root and a heavy script. In the root, we connect the controller using the URL /system/heavy. We call a heavy process in the controller. You can find it in the service. As we can see, this is a huge cycle that will load our processor. Let's send a request to the Postman client. We create a request and send it. See that our request is blocked and our system is overloaded. It is currently unable to accept requests. We can verify this by sending a parallel request. But it will wait for the execution of a heavy script. And after that it just gets done. Let's go to the Docker client. Open the container console. Let's install a utility to monitor CPU usage. Let's go to the README file and enter the following commands. 1. Update our installation package. 2. Install the cop utility. Let's go into it. This shows all the commands that were run in the container. CPU load. The allocated memory for the container. Let's open Postman and send a request. We see that the processor is loaded at 100%. And this means that while it is overloaded, our service will not process any actions. You can partially solve the problem using the PM2 cluster. Let's go to the official site. We can see a picture, which shows the main idea. We must create a few processes and allocate new resources to them with the CPU. A little lower there is a command to run. Let's look at the diagram. And as I said earlier that we have to allocate memory for each process. And in this way, everything will work fine for us until we turn to the overloaded process. As you can see, requests using core 2 and 3 will be processed. But the request that gets to the core 1 will not. Because this core 1 uses a heavy script. Let's see in practice. Let's select 3 cores. We need to restart the service so that additional cores are connected. We go to the console and see that we have 3 processes. Now we make requests and look at the console and at the loading of processes. As we can see, this method is not very suitable for this problem. The chance to get on an overloaded processor is very high. And for this we will consider another way. More information about forking and spawning child processes can be found on the official website in the documentation. There are also examples and various implementation options. But let's take a look at the diagram. As you can see that we will not use the main process for execution. We will spawn a new child process that will solve our problem. Let's look at the implementation. In the controller, we do the following steps. 1. Create an object to call child processes. 2. Create a child object by passing the path to the heavy script. Let's take a look at it. We go to the service and open. Very simple, we hang up an event and call a heavy script. At the end, we send the result of the script if necessary. Three, we can pass data to the child process. 4, we accept data from the child process and log. 5, we log about the successful or unsuccessful closing of the process. We open everything you need for testing. We send requests. We see that everything works for us and we can immediately send several requests at the same time and everything works fine. We look at the logs and see the successful work of the heavy script. But be careful, because such actions are very heavy on the central processor. And so let's move on to the most common and popular solution. This is a publish and subscribe pattern with service clustering to process a heavy script. You can also find detailed information on the official website of the Rabbit. And we will move on to the diagram and consider the basic logic. There are 3 main stages of this pattern. 1, we send a request to the service to publish. 2, the service accepts the request and publishes it to the message broker in our queue. 3, the service is scaled to several child processes and subscribes to the queue waiting for new messages to perform tasks. Let's move on to the implementation. For the publish and subscribe pattern, we will use the amplib module. So the first thing we need to do is install it. Let's go to the console and write the command. Next, consider our publisher. We look at the root. This request will send a request to add a task to the queue. Let's go to the controller. It's simple, we call the service and pass parameters if necessary. We open the service. 1, connect to the Rabbit server. 2, we create a communication channel. 3, connect to the task queue. 4, send a message to the task queue. We can notice that we have a new config constant, task service name. Let's install it and rebuild the service. We go into the Docker Compose file and define. Next, we will rebuild our service. Let's now build our task service, subscriber. Let's look at the configuration in the environment file. Let's look at the Docker Compose file. We see that we have nothing new. Let's knock him down. Open the console and build. Let's check our task service. Let's open the Docker client. We see that services have been created. Now let's open the browser on the port that we specified. We see that everything is fine, our service has been raised. Let's look at the implementation of the subscription and running the task. Let's open the build file task.js. At the bottom we will connect our subscription module. Let's go to the module. 1, connect to the Rabbit server. 2, connect to the channel. 3, subscribe to the queue. 4, perform heavy task. Let's look at work. Let's open the Postman client and create a request. Let's send a request. We see that everything is working fine. We look at the logs and see that our cluster and subscription are working fine. We did a great job, very well.